Okay, guys, this is the last section of chapter 11. It's adding and subtracting rational expressions. We've looked at simplifying, multiplying, and dividing rational expressions, and now we'll add and subtract them. So one term you'll need to be familiar with as we prepare to find common denominators before adding and subtracting these rational expressions is the lowest common denominator, or LCD. It's where we find the lowest number that all the numbers will go into, and the highest variable amount. So if you look down here at the examples down in the bottom, you can see with the 4 and the 7. So typically what I do is you can go ahead and break it down using your factor tree if you'd like, and find the lowest number that all numbers will go into by taking each factor represented between the two numbers and then multiplying them together to get your LCD. You got to make sure you take the highest power of each factor represented. Or you can start with the bigger of the two, if we're just looking at two of them, like the 7, and ask yourself the question, will 4 go into 7? If it won't, then you've got to double 7, multiply 7 by 2, so you get 14. Does 4 go into 14? No. Triple it. Does 4 go into 21? No. And then finally, does 4 go into 28? Yes, you just keep doubling, tripling, eventually multiply by 4. Now, you may be thinking, well, I could have just done 4 times 7 in the beginning. Well, that's true in this case, because if you look at the factor tree here, the 4 can be written as 2 times 2. 7 is just 7 and 1. If I take and collect all the factors represented to the highest power, between these two numbers, I have a 2 squared and a 7, and that equals 28 in the first place. So, you know, just because the factors that were involved in each one were different factors, that's why we ended up multiplying 4 times 7 to get 28 for the LCD. If you're working with parentheses on here, let's go back, sorry about that. The LCD is one of each piece or quantity. I'll show you what I mean by that. We get down over here on the right, down over here, and here as well. But let's go ahead and do the second one on here, the LCD of 3x and 8. In terms of numbers, 3 does not go into 8, so you would take 8, multiply it by 2 to get 16. 3 will not go into 16, so you'd multiply it by 3 to get 24. 3 does go into 24. That is the lowest of the numbers that both 3 and 8 will divide into. And then I need to take the variable with the highest power on it. We've got x in there, so we've just got an x to the first power. And so 24x is the LCD there. Look down below. Let's hit a couple more of these subtraction ones. 15 and 5. Right away we see that 5 goes into 15, so therefore the LCD is 15. And the one next to it, we've got a 10 and a 6. 6 will not go into 10. If you double 10 to 20, 6 will not go into 20. And then you triple 10. 3 times 10 is 30. 6 will go into 30. That's my LCD in terms of numbers. And then what we mean by the highest variable amount is we have an x to the third, which is the highest variable power on the x's between those two factors. Okay, coming back to the idea with working with parentheses, you could even think of parentheses as being around this and this. Because x does not divide into x minus 4, nor x minus 4 into x, nor any multiple of them, they are two separate factors. And so the LCD is actually one of each piece, or x times x minus 4 is our LCD in that case. Down here we've got an x plus 2 and an x minus 1, and then also an x minus 1. So notice there is an x minus 1 that's common in each, but there is also an x plus 2 as well. And so you have to have both factors represented. If you were to divide the x minus 1 into the x plus 2, x minus 1, it would go in. Go into it, and so that takes care of that x minus 1 factor. But we also have an x plus 2 factor represented as well. So that's the LCD. We're going to be using that to get a common denominator before we add and subtract. We're going to start simple though. just starting with some problems that already have common denominators. So when you have a common denominator, draw a fraction bar, list the common denominator on the bottom, go ahead and add the 4 and the 7. 4 plus 7 is 11 over 3y. Check to see if there's any canceling, simplifying that needs to be done. There isn't in this case, we're done. Same thing here. We've got a common denominator of x minus 2. Go ahead and add 3x and x. We get 4x. And we are done at that point. There's nothing that can be simplified out. Go ahead and try on your own the next one with a common denominator. I'll put up the solution. You can check. All right, so go ahead and check your solution. Hopefully you got the same thing as me. I'm going to move on to the next one. Here's a little bit of subtracting with common denominators. So a little bit of a trick here. You got to think of it, this is an unwritten set of parentheses in the top of that second fraction, for which the negative sign will get distributed to each. So what I typically like to do is go ahead and write down the common denominator between the two. Then go ahead and simplify the top. Let's try that again here. So we've got 7x plus 5 minus 4x. Let's extend that thing out a little bit more. So minus 4x and minus 3 on the top of that fraction. So we're going to combine like terms on the top and write our final answer. 7x minus 4x is 3x. 5 minus 3 is 2 all over 3x squared minus x minus 2. Now, there's one other thing we need to check for, and that is whether or not we have any simplification that can happen. This takes us back to section 1 of the chapter. Given a rational expression, could we factor and then cancel? Let's go ahead and check and see what the factors of 3x squared minus x minus 2 would be. Remember, we multiply a and c together to get negative 6. Looking for factors of negative 6 that add and equal negative 1. If they exist, this can be factored, and if those factors match the 3x plus 2, it will simplify. So we've got a negative 3 and a positive 2. If I divide through by the leading coefficient 3, 2 factors, they are on the bottom. X minus 1 is one of them. The other one is, remember, bottoms up. 3 comes up, pairs with the x, plus 2 is the other factor. On the top, I've got 3x. Oh boy. Give me a moment here. Get this re-rotated back. There we go. All right, back to the pen. So 3x plus 2, having good times with new technology for me. Get used to it here. So notice that the 3x plus 2's match. We can cancel. Remember, it's canceling to equal 1. Final answer, 1 over x minus 1. So that's that example. So that's subtracting with common denominators. Don't forget, might need to simplify. All right. Let's go ahead and try the next one here. All right. 2 over z plus 3 minus 7 over z plus 3, common denominator. Subtract the 2 and the 7 to get negative 5 over that common denominator z plus 3. Over here, we've got 10n minus 4 on the bottom. Then we've got 9n minus 3. And then don't forget the magic written parentheses here. Minus 3n minus 5. Go ahead and combine like terms. We've got 6n minus 8. Looks like there's a potential here for some simplification. So factoring out a GCF here on the top of 2 leaves me with 3n minus 4. And factoring out a 2 from the bottom leaves me with 5n minus 2. Go ahead and divide 2 by 2 to get 1. Final answer is the 3n minus 4 over 5n minus 2. Got that. Go ahead and try this last one. 7x minus 3. Forget the unwritten parentheses. Minus 6x plus 5 all over x squared minus 4, which we'll note is a difference of squares, can be factored. 7x minus 6x is x. Negative 3 plus 5 is plus 2. Factoring the difference of squares on the bottom gives me x plus 2, x minus 2. And canceling the x plus 2's, end up with 1 over x minus 2 is my final solution. So check those ones out. Make sure we got those right. And we're going to move into addition and subtraction with unlike denominators. So here they are, 5 over 6x plus 3 over 2x squared. We've got to find the LCD first. So LCD of these two, I can see that the 2 goes into the 6. So 6 should be part of the LCD. I'm going to take the highest power on x that is involved between those two bottom parts of the fractions, that is x squared. So I've got to make a first fraction have a 6x squared in the bottom. It's not a problem. I can multiply the bottom by x. But if I'm going to multiply the bottom by x, I also have to multiply the top of that fraction by x. So I'm not changing the value of the fraction. I'm multiplying by a very carefully chosen value of 1. X divided by x is 1. So there's my multiplication here. All right, 2x squared, I really need that to equal 6x squared as well. I'm going to have to multiply top and bottom of that by 3 in order to accomplish that purpose. So my new set of fractions with a common denominator of 6x squared is 5x over 6x squared plus 9 over 6x squared. Finishing that off, 5x plus 9 are not like terms. I would just leave it in binomial form as 5x plus 9. Place that over the common denominator, 6x squared, and I'm done. All right, let's try the next one here. All right, use a different color as well. So LCD first. The 4 doesn't go into the 6, but if you double the 6, you get 12. 4 does go into 12. So 12 is the lowest common denominator. Just take that bigger of the 2, which is the 6, and you start multiplying it by 2, and then 3, and then 4 until you find the first number that 4 goes into. In terms of variables, I'll take the x to the first power. So I've got to get a 12x on the bottom of each of these. So I'm going to have to multiply the first fraction by 2x over 2x, so that 2x times 6 will give me 12x, and the other fraction by 3 over 3, so that the bottom will be 12x. I end up with the following fractions: 10x squared over 12x plus 9 over 12x. Adding the top, notice that they're not like terms, so I'm going to keep it 10x squared plus 9, and then the bottom just remains 12x. That's it. All right, go ahead and try this next one on your own. Go ahead and pause the video. I'm going to work it out here, and then you can check your answers. right, so final answer when we combine them should be 9 plus 14y to the second over 21y to the fourth. And that is it. All right, one more example to try here. This is one that involves binomials. Think of them as being in parentheses. Neither d minus 1 or d plus 2 have anything in common. So what we need to have as the least common denominator is both of those. So what I need to do here is go ahead and multiply the first fraction by d plus 2 over d plus 2, and the second fraction by d minus 1 over d minus 1, so that both fractions have a d plus 2 and a d minus 1 as factors in the bottom of the fractions. So what this looks like is I've got a 3 that has to be distributed to the d plus 2, and I have a minus sign in there and a 2 that has to be distributed to the d minus 1, and all of that is over the common denominator d minus 1 d plus 2. Now doing a little bit of distribution here, we got 3d plus 6 minus 2d plus 2 all over that common denominator d minus 1 d plus 2. And combine like terms. When I combine like terms, 3d minus 2d is d. 6 plus 2 is 8. And I've got over d minus 1 d plus 2. And if nothing can factor or simplify, then I'm done. All right, I'm going to put the solution up to this last one. So think of this as c times c minus 2 minus 4, don't miss that minus sign, times 3c minus 1 all over 3c minus 1 times c minus 2. Distributing, I get c squared minus 2c minus 12c plus 4 all over 3c minus 1, c minus 2. Combining like terms gives me c squared minus 14c plus 4 all over 3c minus 1 c minus 2, and I'm looking at this quadratic trinomial c squared minus 14c plus 4. Check to see if it can be factored, because if it can, it might simplify. So look for factors of 4 that add equal negative 14. My only factors of 4 are 1 and 4 or 2 and 2. In neither case do those add up to negative 14. Try to look at the negative 1 and negative 4, that adds up to negative 5. So it can't be factored. We can forget about that. We're going to just leave it as is. So that's our final solution. Alrighty, so go ahead and write your summary.